All right. Good day, everyone. Welcome to Chemistry with Professor John. Okay, we are discussing acid base equilibria. Okay. Okay. Francis Plowry define that if a compound donate a proton, which is H plus, it is an acid. And if a compound accept proton, which is H plus, it's a base. Okay. Um, so that would be, say, HCl. Donate H plus. Okay. And then ammonia will accept H plus, give us ammonium ion, right? So that's acid, and that's a base. A species or compound that can either accept or donate a proton is called amphiprotic. Okay, it can do both ways. An example would be water. Water can accept, because water is H plus OH minus. So it can accept electron. I mean, it can donate H plus or accept H plus. Okay, so if water accept H plus, it's become H3O plus. It's pretty cool. And here we go. Donate H plus, become OH minus. That's a base. Accept H plus, become NH4 plus. All right, so that's the overall equations. Water, in this case, act as an acid, and ammonia act as a base. Okay, a base H plus. Okay, now water in this case is a base because it's accept H plus, and of course it's an acid, donate H plus, or losing H plus. You can think about that way. Notice an acid become conjugate base, and a base become conjugate acid. Okay, again, acid, base. So water is really cool. Water can be both. Okay, we should say conjugate. All right. So overall, water can act as an acid or a base. One act like an acid, donate the hydrogen. The other one acts as a base, take the hydrogens. So if we look at the Kw, which is equilibrium constants for water, okay, it's 1.0 10 to minus 14. So that's not large. Okay, obviously water is a neutral compound, doesn't make a lot of ions. Okay, so Kw is really small, 10 to minus 14. And if you look at the formula, those are the two products, and divided by reactant, which is water, and that's liquid, so we can leave those out. So basically just H plus times OH minus give us equilibrium constant for water. So if you split that in half, if the H plus is greater than 10 to minus 7, then the OH minus must be less. And as we call solution is acidic. So take more than half. And if OH is more than half, then it's basics. Now, if we think about pH, because Kw is 14, so we define 14 it's a good scale for pH, and that will be pH plus pOH equal to 14. You probably heard about it already. Acidic pH less than 7, neutral right on 7, that's when the two equal, and then greater than 7, that's basic, when OH minus is greater. Okay, we have some example here, acid and bases. And then some of them are really strong acid that undergo complete ionization in water to give to donate 100% of H plus. And we also have some really weak acid. Okay. On the other side, of course, we have weak base and strong base as well. Well, some acids are strong, like example, hydrochloric acid, hydrobromic acid, and so on and so forth, nitric acid. And they dissociate 100%. Okay. Like HCl will be 100%. Or we can write there you go. Some we do have some bases as very strong as well. That's completely dissociate to give us OH minus. Okay, we can measure pH by pH meters. It could be a portable one or the complex setup. pH paper will help us to, or indicator will help us to estimate the pH. Okay, let's take a look at the strand of some acids and bases. Okay, the strong acid will give us 100% or nearly 100%, but the weak one, it's a lot less. Okay, so that's how we can tell. Everything is equilibrium. These are the good strong one, popular one, like perchloric acid, all the halogen one, except the fluorine. The alkali metal and some of the alkaline earth metal hydroxides are strong. Okay, so now weak acid, right? They don't dissociate 100%. So it's reversible. So we got Ka, we call it a Ka. And remember, K is product over reactant. And then aqueous only. Okay, if it's liquid, leave them out. Like water, leave them out. Okay. All right, so what do we got? The larger Ka is the stronger the acid. Of course, gets more product. And H plus is a product. And of course, smaller Ka, weaker the acid. Bases, the same idea. And then we do Kb, okay? And of course, you know, the larger Kb, the stronger the base, meaning more OH minus. Now, Ka and Kb's are inversely related. All right. And for HA to donate a hydrogen plus, it depends on the stability or the strength of A minus. If A minus is not is strong, of course, as soon as it's release the H plus, it take the H plus and go back to the original acid. Okay, now let's keep going until move forward to the calculation part. Here's the comparisons of the Ka value. They're all pretty small. Okay, you go from strong acid, pretty high Ka, and weak acid, very low Ka. Same for Kb. Okay. Acid again. Now, how do we figure out Ka and Kb, right? That's the key, okay? And this percent ionizations. All right. How do we figure out Ka and Kb, and how do we calculate pH? Keep going. Okay, back to the equilibrium that we learned last chapters. So let's say we start out with weak acid initial concentrations, and then the change, let's say, is not much. Okay, and then final equilibrium, we got that. Now, so to solve for Ka in this case, we take 0.0046, that's the product, times 0.0046, that's another product, divided by 0.0470. Okay, so you put in your calculator, that's the Ka. Now, we don't have to include water because it's a liquid. So water is not part of the equations. Now, when you get the Ka, the pKa is minus log of Ka. Okay, you got to put it in your calculator and see what you got. All right. Now, if you know pKa, I mean, you know Ka, you can solve for this. So let's say x squared divided by 0.534 minus x, and that's equal to Ka. And most of the time, we can negligible if x divided by 0.534 times 100, right? If it's less than 5%. And plug in the value of Ka, we solve for x, okay? Here's another one. You can look up acetic acid, Ka, and we can solve for x. All right, so we'll do this calculations in the class together. This is a good practice to solve for x, which after you solve for x, okay, when you solve for x, that's the H3O plus, which is the same as H plus equal to x. And then after you solve for x, you can calculate of which is minus log of x. you can solve for pH. It's very cool. So if we know the initial concentration, and we know pK, we know Ka, we can solve for H plus concentrations, and therefore we can find pH. All right, thank you everyone. We'll see you in the next video.